Ever wonder what really happens in that split second after you type in a website and hit enter? I mean, how does your computer possibly find something like Google.com in the vast, vast ocean of the internet? Well, the answer is this beautifully elegant system that works just like the internet's own address book.
Think about it like the contacts list on your phone. You don't memorize everybody's phone number, do you? Of course not. You just search for their name, and your phone does the work of finding the actual number to make the call. The internet works in the exact same way. We, as humans, remember names, like Google.com. But computers, they need numbers, specifically IP addresses, to connect to anything.
And that right there, that translation from a simple name to a super specific numerical address, that's one of the biggest challenges the early internet had to solve to even be usable for regular people. The solution? A system we call DNS.
So DNS stands for the Domain Name System. And you can just think of it as this massive automated global contacts list for the entire internet. It's a huge distributed system, and its main job is to do one thing really well: translate the website names we type in into the IP addresses that computers actually understand.
I mean, just imagine for a second if DNS didn't exist. Instead of typing Amazon.com, you'd have to remember and type something like 176.32.98.166 for every single site. It would be a total nightmare, right? The internet as we know it just couldn't exist.
So how does this magical translation actually happen? Let's follow the journey your request takes every single time you look for a website. It's this incredible, high-speed conversation happening completely behind the scenes.
The whole thing is basically a 6-step digital relay race. It all starts in your computer, which kicks off this question that bounces between several different specialized servers, and each one has a very specific job to do. Okay, so the very first step is always about taking the shortest path. Your computer checks its own short-term memory, what we call a cache, and it asks, hey, have I been here recently? Do I already have this IP address written down? If the answer is yes, the journey's over right then and there. You're connected instantly. But if it's a new site or one you haven't visited in a while, your computer needs to ask for help. It sends the request out to its designated partner in crime, a recursive DNS server. This is usually run by your internet service provider, like Comcast or Verizon. Now, to make this whole journey really make sense, it helps to kind of personify these servers. So let's think of this as a detective story, where each character plays a crucial part in cracking the case.
Our main character, our detective, is the recursive server. Now, this server doesn't know the answer itself, but its whole job is to promise, I will find it for you. It's programmed to hunt down that IP address, no matter how many other servers it has to ask.
So the first place our detective goes is to one of the 13 sets of root name servers that are scattered all over the world. These servers are like the master index for the entire internet. They don't know the specific address for, say, Google.com, but they know who's in charge of all the .com websites. They give our detective its first big clue.
Following that lead, our recursive server now goes and asks the top-level domain server, or TLD server for short. This server is the manager of all websites that end in .com. And again, it doesn't have the final answer, but it knows the next critical piece of the puzzle: the exact server that holds the official records for SomaliNewsTV.com.
And at last we arrive at the final destination, the source of truth, the Authoritative Name Server. This server holds the official, definitive record for that specific website. It checks its files, finds the match, and gives our detective the final answer: the correct IP address. Case closed. So now our heroic recursive server has the answer. It zips that IP address back to your computer, but, and this is the really clever part, it also saves a copy of that answer in its own cache. This is the secret to why the internet feels so fast. The next time anyone on your network asks for that same site, our detective doesn't have to do all that work again. It already knows the answer.
But it gets even cooler, because the job of DNS goes deeper than just finding a website's address. These authoritative servers, they're in charge of a whole menu of different types of information for a domain.
This is where DNS really shows off its flexibility. So yeah, the A and AAA records are the most common. They point to a website's IP address. But look at that MX record. That has nothing to do with websites. It tells the internet where to send email for that domain. So the exact same system that gets you to your favorite blog is also making sure your emails land in the right inbox. Pretty cool, huh?
So we've got this whole multi-step journey, right? Our detective server is hopping across the globe, talking to all these different managers and indexes, all just to find one little piece of information. I mean, that sounds like it should take a little while, doesn't it?
Well, here is the absolute magic of this entire system.
That whole conversation, from your computer to the detective to the root to the TLD to the final server and all the way back again, typically happens in about 25 milliseconds. It is literally over and done before you can even blink your eye. It's just incredible.
So, to wrap all this up, what are the key things to remember? First, DNS is the essential invisible backbone that makes the web work for humans. Second, every time you go to a website, you kick off this lightning-fast, multi-step journey across the internet. And finally, it's this whole process happening in the background that makes the internet feel so seamless and instant.
And I'll leave you with a final thought to chew on. Just take a second and really try to picture it. A world with no domain names, only numbers. An internet where you had to remember every single address. What would we even use an internet like that for? It's really the silent, brilliant work of DNS that gives us the web we know and love today.